Number 14. For the set of 9 scores shown here, and by the way, notice that they are arranged in order from lowest to highest. That's going to come in handy, especially when we do part B. But part A, construct a stem and leaf plot for the data. The stem is made up of the first digits of the numbers, and then the leaves are the units digit. So the number 52 would have a 2 growing off the stem of the 5. Here's 58, 61, 69, 71, 77, 81, 85, and 90. And I've made them all the same size and lined them up. I did not put commas between them. I just wrote the numbers, and how far out they go shows me how many numbers there were in the 50s and in the 60s and in the 70s. I have the same number of numbers in the 50s and the 60s and the 70s and the 80s, so these are all the same width. If I just colored them in and made them a solid bar, those bars would go out the same distance here, 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 and here, and only half as far here because there's only one number in the 90s. Now for the 5-number summary, remember that's the 3 quartile numbers, Q1, Q2, and Q3, and the minimum and maximum. So Q2 is the same as the median of the whole thing, and that would be 71. Q1 would be the median of the numbers that are below the overall median. So if you look at these 4 numbers that are below 71, the median of those would be halfway between 58 and 61. To find what's halfway between them, we can add them together and divide by 2. They add up to 119, divided by 2 is 59.5. So that's Q1. And then Q3 would be, if we go back to the median and now look at the numbers that are above the median and find the median just of those 4 numbers. That would be right here, halfway between the 81 and the 85, which would be 83. And the minimum of all the numbers is 52, and the maximum is 90. Now the box and whisker plot is based on these 5 numbers, and it looks like this. Notice I've got a consistent scale marked out. I've got it going up by 5s with the same amount of space between each number and the one that's 5 bigger. And then I've marked out the box that stretches from 59.5, just a little bit to the left of 60, all the way across to 83, which is between 80 and 85. And in between those, I've drawn a line showing where the median Q2 is at 71. And then the whiskers growing off the sides of the box, I've got one of them that goes over to the left to 52, and then one over here on the right going up to 90. So there's my box and whisker plot. And from looking at this, would you say that looks like it is positively skewed, that is skewed to the right? Or negatively skewed, that is skewed to the left, or symmetrical? Well, it looks to me like both halves of the box are about the same size, and both whiskers are about the same length as each other, so I would say this is symmetrical. Number 15. Shown below is a frequency distribution for the length of time it took the 30 children in a random sample to complete a skill test, in minutes to the nearest minute. So looking here, the class limits are 3 to 7, 8 to 12, 13 to 17, 18 to 22, and 23 to 27. So that means that some of the kids took somewhere from 3 to 7 minutes to complete the skill test. Some of them took 8 to 12 minutes. Some took 13 to 17, some took 18 to 22, and some took 23 to 27. And the frequencies, the numbers given in the frequency column, tell how many children there were in each class. There was just one kid who finished in somewhere from 3 to 7 minutes. 10 of them took somewhere from 8 to 12 minutes. 12 of them took 13 to 17 minutes. 5 took 18 to 22. And 2 of them took 23 to 27 minutes. So from this, we can fill in some other things. The class boundaries, well, like for the first class, the lower boundary would be 0.5 below the lower limit at 2.5, and the upper boundary would be 0.5 above the upper limit at 7.5. And then for the next class, it goes from 7.5 to 12.5. For the next class, it's 12.5 to 17.5, and so on. Notice that just like the lower limits go up by 5 each time, and the upper limits go up by 5 each time, also the boundaries go up by 5 each time. And the upper boundary of one class is exactly the same as the lower boundary of the next class, because that number is the boundary point separating those two classes. If you're on one side of 7.5, you're in the first class. If you're on the other side of it, you're in the second class. For the cumulative frequencies, cumulative means they accumulate, they add up. So we start with just 1, but then 1 plus 10 is 11, plus 12 is 23, plus 5 is 28, plus 2 is 30. And for the midpoints, halfway between 3 and 7 would be 5. Maybe you can just see that, but if you can't, you can add them together and divide by 2. 3 plus 7 is 10, divided by 2 is 5. 8 plus 12 is 20, divided by 2 is 10. So halfway between 8 and 12 would be 10. Then we got 15, 20, and 25. And just like the limits and the boundaries, the midpoints also go up by the same amount each time. B, how many children took less than 17.5 minutes to complete the test? So remember what this is telling us. There was one kid who took somewhere from 3 to 7. Before being rounded off, that would have been somewhere between 2.5 and 7.5, but it would have been less than 7.5. Then there were 10 kids who took less than 12.5, and 12 kids who took somewhere between 12.5 and 17.5. So anybody in those first 3 classes, the amount of time they took was somewhere under 17.5 minutes. So altogether, that's the one kid who took somewhere between 2.5 and 7.5, plus the 10 who took somewhere between 7.5 and 12.5, plus the 12 who took somewhere between 12.5 and 17.5. 23 in all. And notice that is the cumulative frequency there. So the answer to that is 23 children altogether took some number of minutes that was less than 17.5. Now, to draw a histogram based on this grouped frequency distribution, here's what it would look like. Notice I've got the horizontal axis labeled with the boundaries, and those are the points that separate the bars. 7.5 is right in between the first and second class. 12.5 marks the boundary between the second and third class, and so on. So these are all the same distance apart, so that the bars are all the same width as each other. And then the height of each bar is the frequency of that class. 1, 10, 12, 5, and 2. And I did use a consistent scale, 0 to 1 to 2 to 3 to 4, and so on. A frequency polygon would look like this. I've labeled the horizontal axis with the midpoints of the classes, 5, 10, 15, 20, 25, and then above each of those midpoints, I go up to a height of whatever the frequency is, 1, 10, 12, 5, 2, then connect the dots and connect them back down to the ground level. An ogive looks like this. it shows the cumulative frequencies. I've labeled the boundaries, and I put my first dot here at the lower boundary of the first class, 2.5, right at 0. Then above the 7.5, I'm up at 1. Above the 12.5, I go up to 11. Above the 17.5, I go up to 23. Above the next boundary, 22.5, I go up to 28. And then above the 27.5, I am up at 30. To find the mean for a grouped frequency distribution like this, I need to make another column for frequency times midpoint, where I multiply together the numbers in the frequency column times the numbers in the midpoint column. So 1 times 5 is 5, 10 times 10 is 100, 12 times 15 is 180, 5 times 20 is 100, 2 times 25 is 50. And I need to add that column up together. I also need to know what the frequencies add up to if I didn't already know that that was 30. And then the mean for a grouped frequency distribution is the sum of the frequency times midpoint column divided by the total frequency. So here that would be 400, that's 435 divided by 30, which is 14.5. So the mean or average number of time it took to complete the skill test, 14.5 minutes. What is the modal class? That's easy if you remember what that means. The mode is the most common value, the value that there are more of than anything else. The modal class is the most common class, the class that has more in it than any of the other classes. So which class has more data values in it than any of the others? That is, which one has the highest frequency? That would be this one. So it's the class from 13 to 17. And what is the standard deviation? This is kind of complicated. If I ask you this at all, it would be a bonus question. But to do it, to calculate the standard deviation for a grouped frequency distribution like this, we need the frequency times midpoint column, and we also need another column for frequency times midpoint squared. And notice it's only the midpoint that gets squared, not the frequency. So that means frequency times midpoint times midpoint. So in the first row, that's 1 times 5 squared, 25. Then 10 times 10 squared would be 1,000. 12 times 15 squared would be 2,700. 5 times 20 squared, 5 times 20 times 20 is 2,000. And 2 times 25 squared is 1,250. And those numbers in that column add up to 6,975. Now, in the formula for the standard deviation, we take n, which is 30, times the sum of frequency times midpoint squared, which is 6,975, minus frequency times midpoint squared, so 435 squared, divided by n times n minus 1, so 30 times 29, and then when we've got that all calculated, we take the square root. So on a calculator, here's what that looks like. Without the square root, it would be parenthesis 30 times 6,975 minus 435 squared, close parentheses, divided by parenthesis 30 times 29, close parentheses, equals, so 23.017 and so on. And if we wanted the variance, that's what that would be. But we want the square root of that number, which is 4.79 something, so about 4.8 for the standard deviation. Okay, we just got a little bit left to do. Come back in part 4 and finish up the last few review problems.